All right, I still see the attendees still going strong, so we'll just give another minute and then we'll get started. All right, well, thank you, everyone. Good afternoon. My name is Ashley Alzinga. I am the Director of Sustainability for the Foodservice Packaging Institute, and we thank you for joining our Plastic Food Service Design Packaging webinar. Plastic Food Service Packaging Design Guide webinar. Say that 5 times fast. Again, like I said, my name is Ashley Alzinga, the Director of Sustainability. Just a few quick housekeeping items that I'm going to go over. This webinar is being recorded. You are all muted. And if you have any questions, you may use the Q&A section to submit questions there. And then also, if you want to ask your question live, feel free to raise your hand and we can unmute you as well. So today's agenda, I'm going to go over a little bit of FPI, some background, who we are and the work that we do. And then I'm going to turn it over to Scott. He's going to talk about the design guides that APR, Association of Plastics Recyclers, and FPI created a few years ago. And then we will save all the questions and answers for the end here. So just some quick background, FPI, we are the trade association for the food service packaging industry here in North America. We were established in 1933. So 90 years, we've been around for 90 years, so it's quite a long time. Our members include converters and their raw material suppliers. So that would be like paper mills or resin manufacturers, and then also the machinery suppliers that make the converting machinery. And we represent about 90% of the industry here in North America, mainly focused on the US and Canada. And then we also, understanding that we don't live in a vacuum, we also work with distributors and food service operators. So those are part of our membership as well. So what is food service packaging, to help kind of set up this conversation that we're having? So food service packaging is the single-use food service ware that our industry manufactures. So this includes cups, including the Java jackets, containers, boxes, paper bags, also utensils, straws, lids, things like that. But for our recovery work, we specifically focus on the cups, containers, boxes, and paper bags. So back in 2011 and 2012, FPI created these voluntary recovery groups. Our industry understood that no one company could do it alone. So they created the Paper Recovery Alliance and the Plastics Recovery Group, PRA and PRG. And, these two groups have been going on for over a decade. Then along came the Foam Recycling Coalition, which is focused on polystyrene foam recovery. And then in 2018, we formed the Paper Cup Alliance, which is specific to paper cup recovery. Here are our current members. As you can see, we have a very large chunk of the supply chain, all the way from the material suppliers to the brands to the recyclers that you see on the list here. And our overview of our approach is, our overall goal is to increase the recovery of food service packaging. So to do that, we understand that we need to increase access. So we need to make sure that the communities and those residents have access. We track that access. we communicate that access to industry stakeholders so that you can use the how to recycle labels, or and then we encourage spontaneous uptake. So if there's a MRF that we are working with, a material recovery facility, you know, and we're working with a particular city, we also encourage all the other surrounding communities that are serviced by that material recovery facility to also include these items in their programs. And so it's kind of it's a feedback loop that we are able to get a lot of great access out of. And then, you know, to underpin all of this is really the foundational work, is really where we started over a decade ago. You know, we had questions like, you know, food residue. So this is our foundational work. So, you know, how much food residue, is it really a problem? You know, how much food service packaging is actually out there? Can it actually be recovered? Are there interventions that are needed, such as equipment, or does the package flow through the system fine? So we work with end markets, we message our findings, we work with MRFs, and then we also do work with composting. So all of this information can be found on our website, recyclefsp.org, or feel free to reach out to myself as well, and happy to talk through all this great work that we've done over the years. And then this is a great infographic that we created on the recovery of our work. So just a few key points here is that, you know, we work with the end market development. You can see we've increased the uptake of paper cups by paper mills from 4 back in 2017 to over 34 today. And then the growing recycling access. This is actually a slightly dated infographic because we are now over that 7 million household threshold. So we've been doing some great work, and as you can see, it's been snowballing in recent years, which we're super excited about. So with that, I will stop sharing and I will turn it over to Scott, who is the technical director for APR, to talk about plastic food service packaging. So take it away, Scott.
Thanks, Ashley, and thanks for the invitation to chat with your team today. And I think, you know, as we look through this presentation and the slides you just shared, we'll see a whole bunch of overlap between FPI and the Association of Plastics Recyclers. So as Ashley mentioned, I'm Scott Trenner. I'm the technical director at APR. And what I'd like to do over the next kind of 45 minutes or so is go through a couple topics that Ashley and I thought would be interesting to this audience. So I'll give an introduction to APR. We'll talk a little bit about the design guide and how it's set up, and then go through the recycling process, both first at the MRF and then at the reclaimer, to kind of give you an idea of why our design guide is set up the way it is, and why the guidance is really there to improve quantity and quality of recycled plastics. And then I'll end up with some general guidelines for a few very common packaging formats. So who is APR? So APR is a US-based international nonprofit. We're the only North American organization focused exclusively on improving recycling for plastics. I think we were founded around 1992, so not quite the 90-year history that Ashley mentioned. But as you look at our mission, it's quite simple. So whereas FPI is focused on single-use food packaging, our focus is simply recycle more plastics to reduce waste. If you look at our membership, we essentially have 2 tiers. We have our core membership, which are really the reclaimers. So that would be the no longer waste management, the WMs, the recyclers like Revolution or KW Plastics. And then our affiliate members are the rest of the supply chain. So whether it be Berry, which I think I saw on FPI side, or other brands such as PepsiCo, testing houses like PFE and Van Dyke, and includes some of the stores like Target, for instance. We have about 290 members at this point. So our 4 goals are to increase supply, enhance quality, expand demand, and communicate the value. And we have a number of programs that are based around these 4 goals, and I'll kind of walk through or introduce a couple of them right now. So On the first side, we have the what goes into the recycling stream. So we have the APR design guide, which I'll touch on in more detail coming up. We have APR global design catalogs that kind of gives you an overview of how other countries around the world view design guidance. APR design guide training, so we can come to your facility and give you about a day-long short course, I would say, on that's targeted to your type of packaging, the issues that you encounter in packaging design, all with the backdrop of understanding how collection, sortation, and recycling works in the US, or in North America, excuse me. We have design recognition. So when somebody comes up with a new innovation, say it's a new label for a thermoform package, and we don't currently understand how that label will affect the recycling stream, we have a set of testing protocols that allow you to evaluate that. And if you pass them, APR has a number of recognition programs to recognize that new innovation. And then we work quite closely with ISRI on model bale specifications, and I have a slide on that later. As we look at what comes out of the recycling stream, so we have the APR Demand Champions program. That's a program that recognizes users of post-consumer recycled plastics, and specifically those that on a year-to-year basis increase their use of PCR. We have a certification program, and that certifies the reclaimers and the pellets that a reclaimer might make, so that when you want to use PCR in your products and you want to make maybe consumer-facing claims, you are certain that that material is post-consumer recycled plastic. And then a buyers and sellers directory. And all of that is also informed by our policy and also education. As a part of education, we have a pretty extensive library on our website. It includes a number of topics from just general terms about recycling to legislation, a number of position papers, and then some reports or white papers that we've published. The ones that are highlighted have been updated within the last 2 or 3 months. So if you haven't been to our website recently, those are good ones to work on. The one I wanted to focus on here a little bit is this degradable additives use in bottles, films, and other forms. And we've recently updated our position on degradable additives, and we get lots of questions about how these additives that are designed to degrade either polyethylene, polypropylene, or PET in the environment, how they affect the recycle stream. And essentially, there are lots of words on the slide, but we're concerned that the use of degradable additives and plastics collected for the recycling may have negative effects, and that they could present technical challenges for mechanical recycling and the future uses of that product. And it's not just kind of I guess I said we're concerned, but there's a substantial amount of technical data that backs that up. So one example here was published a few years ago. And what they did was very simply is they took a pro-degradant additive and they put it in a polyethylene film. They exposed that film to UV degradation per the ASTM D5071, which is the standard practice for exposing photodegradable plastics. They then ground that exposed plastic up and reintroduced it to virgin low-density polyethylene at 1, 5, 10, 20, and 50 weight percent. And when they tested the mechanical properties, you could see that even at 1% of that degraded material, the tensile strength decreased by about 50%. Elongation at break increased by more than 50%, and the properties continued to become more degraded with additional degraded material. So again, very small amounts of these degraded materials can have a substantial effect on the recycle stream. And if you look at our policy or our statement on this, we're really in line with other organizations. So the Ellen MacArthur Foundation, the EU Single-Use Plastic Directive, NAPCOR, Recyclass in Europe, Sustainable Packaging Coalition, US Plastics Pack, Walmart Recycling Playbook, and WWF. None of them, or all of them, align with us. None of them support the use of these materials or additives in plastic packaging. So shifting gears to our design guide, The question we get asked most often, and the question you probably ask quite a bit is my packaging recyclable? And our design guide is the tool to ensure that your package is compatible with the North American recycling system. I would say it's one of 4 criterias that are needed to make unqualified claims in the US per the FTC design guides or green guides, excuse me. Design for recyclability is the one that we, I guess, hold closest. Consumer access to recycling, acceptance of a package in the recycle stream, and then end markets for the products made from that recycled plastics. So as we dig into a couple of the other ones, the one I'll pick on first is US recycling format access. So this plot was taken and changed slightly with the 60% line, which is the FTC minimum, from the updated 2021 SPC centralized study on availability of recycling. So per the FTC green guides, US population or greater than 60% of the US population has to have access to a recycling program to make an unqualified claim. And the plot is a little bit fuzzy, but you can see that, PET beverage bottles, PET jugs and jars, they both meet that. So green is, explicitly accepted at MRFs. The lighter green is implicitly expected, purple is unclear, light blue is implicitly prohibited, and then the darker blue is explicitly prohibited. So PET clamshells are pretty close. I think they're at like 55 or so percent now. PET cups are a little lower than that. High density bottles, jugs, and jars meet access. Polypropylene bottles, jugs, jars meet access. Polypropylene tubs, I think, are at 59% is the most recent number I think I've seen them. Low density meets the requirements for both for the bottles, but not necessarily for other containers. And then polystyrene here is well short of that 60% access. So when we think about polystyrene packaging and our design guides, one, APR has not updated our design guide for polystyrene package, mostly because it does not meet the access requirements. Recently, we and ISRI, the Institute of Scrap Recycling Industries, updated our model bale specifications, and these were published in November of this year. So the polystyrene, rigid, and foam resin model bale specifications have not been updated due to the access and limited market activity for those commodities. So where would polystyrene go? It is sort of, I guess I would say, accepted in the small rigid plastics bale. So this bale is a positive sort, so it cannot be made from the residual of a sorting facility. It should be primarily polypropylene, PET, and high density. Total contamination should not exceed 15%. And as part of that total contamination, polystyrene is allowed to about 10%. So what happens if polystyrene ends up in one of these bales? Well, it kind of depends on who buys that. If it goes to a processor or a perf that handles 3 through 7 bales, it might end up in I guess I would say a polystyrene heavy stream available for a reclaimer to purchase that. If it goes to a polyolefin recycler, it would be lost during the sink float, or if not earlier during sortation, and end up in the landfill most likely. Sorry, my dog just woke up, so you might have heard some jingling in the background. So if we move from the polystyrene to the common packaging formats that SPC says that meets the minimum access, we can look at PET bottles, polypropylene rigid packaging, high density rigid packaging, and polyethylene films through store take-back positions. It's really the APR design guide that's the criteria that's needed to make recyclability claims. So regardless of which format that we're looking at, the APR design guide looks at an entire package as a compilation of design features. So we have a yogurt or cottage cheese container here, right? So if you look at our design guide, we not only talk about the polymer that container is made out of, but any other barrier layers, additives that go into that, the inks that are printed on either directly on the package or on a label that's on the package, the adhesive that's used to attach that label on the package, the size of the container, the color, attachment, shapes, and even you can see the little diagram or figure that we have here, although it's not pointed out, is the lidding that might be used on that container. And each feature is classified into a specific recyclability category. The top of the line is APR design preferred. Below that is detrimental to recycling. Below that is renders the package non-recyclable and then requires testing. And I'll go into a little more detail on what each of these mean. But as we look to design packages, what we really strive for is to push for that preferred design. And as we think about growing the circular economy, and as you on this call want to use more recycled materials into your own packaging, as you design packaging and put it on the market, you're essentially studying the specifications for your future raw materials. So as we move and look at preferred, those are designed and design features that have the maximum quality and yield in whatever type of packaging you're making. Whereas detrimental, that package still might be recyclable, but there's some issue where we're reducing yield or quality. So really striving for preferred design is where we get to a point where we are benefiting the circular economy by creating raw materials that are usable back into our original packaging. So as we take those features and build up an individual package, right? So we have a water bottle or some sort of bottle here, and we have each one of our design features. And in this case, they're all the preferred by APR design guidance. That package is considered a preferred design for recycling. Again, highest yield, highest quality in the recycle stream. If any one feature is detrimental, this one happens to have 3 detrimental features, but if any one is detrimental, that package we term as tolerated but needs improvement. And again, we understand that in many cases, some of these detrimental features, they're used for either processability in the original package, or maybe they're a lower cost, right? So we understand that there's cost and effect in moving the preferred design. But again, you are the ones that are designing and specifying, setting the specifications for your own raw materials. And then finally, if any one feature is not recyclable, that entire package is not recyclable. So what happens when those packages are put into the recycling system? You know, a preferred design for recycling, again, it's processable by the recycling stream and it produces the highest quality PCR available. Tolerated but needs improvement, it's still processable by the recycling stream, and we still want it in there to increase volume. But we do acknowledge that there might be lower quality or some sort of hit on the yield, and non-recyclable ends up in the landfill, and it might be even worse than that, right? It could go into the recycle stream, which then the MRF pays to sort that material. So, and then landfills it at the end of the day. So not only does it get landfilled, but it adds costs to the entire supply chain. So where do our assessments line up with other organizations? So if we start with the Recycling Partnership, their pathway to circularity aligns with our preferred design. The US Plastics Pact definition of recyclable aligns with our preferred design. California, or recyclable by California law, spans both preferred and tolerated. So again, materials that are recyclable, and I'll have a little bit more detail on the next slide on that one. And then SPC, there's a little bit of overlap depending on what some of those features are. I think a good example of something that they have a widely recycled label for that we say is tolerated but needs improvement is a gallon milk jug with a paper label on it. That paper label is detrimental, but that gallon milk jug is very valuable in the recycle stream, and we definitely want it there. So a little more detail on California. So the 2 regulations that I'll touch on is Truth in Labeling, SB 343, and the California EPR program, SB 54. So SB 343 has 4 criteria to be labeled recyclable. One of those criteria is compliance with the APR design guide. So essentially what that means is if APR says a design feature causes a package to be not recyclable, that package will not be considered recyclable in California. And with EPR, there's verbiage in that legislation that allows for higher eco-modulation fees or higher plastic taxes, packaging taxes, if you will, for products that contain features that are detrimental to recycling per our design guide. So a little bit about the design guide. So how is it based? How does it work in reality, right? So the first kind of set of our testing are based on the MRF sorting processes. So taking a recycling truck from a tipping floor to these nice, neat bales that are shown here. And if we look at the process that a piece of packaging or goes through at a MRF, right, it's quite complex. So sortations at MRF start first by size, then by shape, and then by material properties. And that's how our design guidance is set up in terms of our sorting protocol. And I'll show how, I'll list them out on the next slide here. But essentially something comes in, bulky rigid, so kitty litter boxes, that sort of thing, come out at the beginning. And then the package goes through a number of screens. So the first takes out corrugated packaging. The second might take out news and ledgers. So again, two-dimensional, lightweight packaging. The third takes out small size. So this typically includes a glass breaker. So the broken glass breaks down, and then anything less than about 2 inches in size and any two of, I would say, 3 dimensions typically will fall into the glass breaker. So this is why APR promotes caps on bottles, because if you try to recycle them separately, they'd be lost into the glass stream. After that, there's a 2D, 3D separation. So again, 2D paper comes up here. There might be a near IR person there for QC to remove most likely flexible packaging from that, plastic packaging. Containers fall, and then we start separating by material attributes. So in this case, we have near IR separation of high density PET, polypropylene, and then an iron to remove magnet, and aluminum or eddy current to remove aluminum. These could obviously be in any order. And then finally, what doesn't get separated out or positively sorted out goes into the residue. So if you look at our sorting protocols, they're really set up to mimic what we'll say is the average MRF, right? So MRFs have been built over the last several decades, but plastic packaging has increased in volume and capture rate over the shorter time frame, right? So all MRFs are essentially configured differently. Some have been retrofitted, but the equipment of an average MRF is what we base our sortation on. And our sortation protocols are based on size, 2D, 3D, which has recently been updated, and you'll probably be one of the first ones outside of APR to see what that kind of looks like. Near IR sortability, and then metallic features. So you can think of an aluminum cap on a PET wine bottle, right? And how that might affect sortation. So some design guide generalizations for sortation. So size, less than 2 gallons. So large containers are pulled out on that bulky rigids at the very beginning. Packages or items that are less than 2 inches in two dimensions will most likely or could be lost in the glass breaker. So if you have a package that's less than 2 inches in 2 dimensions, we have a sorting protocol to show whether that will most likely be sorted in or lost in the screen. Metal containing pigments, foils, we have a sorting protocol to ensure that those don't adversely affect sortation in the plastic package that those features are on, make it into the right plastic stream. Dark colors, so historically black plastics have not been able to be sorted. There are a handful of new dark colored pigment formulations that allow for near IR sortation, and we have a sorting protocol to show whether a dark colored object will be properly identified and sorted. And then also a sorting protocol for labels. So for large, high coverage labels, full body shrink sleeves, wraparound sleeves on thermoforms, we have a sorting protocol that you could use to test your package to understand whether that label will adversely affect the identification of the package. And finally, 2D, 3D. So I'm going to try to work my way through these next slides. I got them this morning, so they're a little bit new to me. So one is 2D, 3D testing required. So as I mentioned before, so if a dimension of the uncompressed package is less than 5 centimeters, I think I used 2 inches in the previous couple slides, but so less than 5 inches or less than 5 centimeters, or if the package is anticipated to be compressed to less than 5 centimeters. And we have a pretty complicated chart that I'll show on the next slide. So testing is not required if the package is larger than 5 centimeters, right, in multiple dimensions, and or it's probably not going to be compressed to less than 5 centimeters. Or if it's a large, heavy, commonly accepted package, like a large carbonated soda bottle, large milk jugs, yogurt containers, that sort of thing. So you probably cannot actually read this, but this will be available on our website. It was, I guess, approved late last week, so it's not on our website yet. But essentially what it does is it lists out the packaging minimum sidewall thickness, and then the smallest allowable dimension in the other, one of the smallest allowable dimensions in the other size. So I'll pick this one right here. So in this case, if your sidewall is 0.44 millimeters and you're making a PET thermoform and the smallest dimension on that PET thermoform is 6 centimeters, you don't need to test. If you're below 6 centimeters, then we would suggest that your package would require testing to understand how it would sort in the 2D, 3D. Right now we have PET thermoforms, PET bottles, and polypropylene tubs. Polypropylene thermoforms and HDPE tubs are coming soon. So that's kind of the sortation upfront process. Now I'll touch a little bit on the plastics recycling, the reclaiming process. So this is when we take those nice, neat bales that the MRFs sort for us, and then our output is either pellets or flake. So as we think about the unit operations at reclaimers, right, there are 4 basic operations. So first is to sort the articles again. And that includes sorting by material and also sorting by color for PET and high density. And we're seeing more and more interest in a clear polypropylene stream. So polypropylene reclaimers may start searching for natural or clear polypropylene. Liberate components from each other. So this is the removal of a label off the surface of a PET bottle, or the cap or closure off the top of a bottle. And then separate those components into independent streams, and then finally cut articles into flake. So one of the most important separation tools besides near IR at a reclaimer is the sink float tank. So if we think of this as a process in PET beverage bottles, right, the round bottle would be put into the sink float tank, the PET would sink and be removed by this auger. The polyolefin closure will float and then removed off the top, and those would create 2 separate sellable clean streams. In polypropylene or polyethylene, they still go through the sink float tank, and most of what they do, or the goal for that, is to remove things that would sink in that stream. So dirt, rocks, dissimilar materials. So as we think about packaging, we really need to be cognizant of the impact of foaming additives and fillers. So for PET, we definitely don't want foaming additives where the density decreases below 1 gram per cubic centimeter and that PET floats, because then it's yield loss for PET and also contaminates the polyolefin stream. And what I'll spend the next couple slides on is mineral fillers for polyolefins. So we've recently updated our density guidance, and the reason why is kind of a good and bad news story. So we've received a letter and confirmed by multiple reclaimers that they're getting more and more takeout food containers in their streams. One reclaimer said that as much as 10% of the weight of the average weight of a bale are these takeout containers. And this is a study from 3 different loads from MRFs in the Northeast. So, I mean, as we try to increase supply, it's great news that these materials are making it into the recycle stream. Unfortunately, many of these packages are heavily filled with calcium carbonate for various reasons, right? So they reduce costs. Apparently it substitutes, some are making claims that it substitutes and reduces the amount of plastic. But when they're filled with calcium carbonate and the density goes higher than 1 gram per cubic centimeter, gram per cc, then a polyolefin recycler will buy a bale of this material. It'll go through the sink float tank and they'll lose it it'll sink and it'll be yield loss and that material will go to landfill. So our updated almost, this is another update since this morning. We've received enough votes to approve the new guidance, but we don't have votes from the entire committee, so it hasn't been updated on our website yet. I've shown the one for polypropylene here, but polyethylene is essentially the same with the exception that it's polyethylene instead of polypropylene. So we'll give a little bit of a background, couple of sentences as to why the guidance is what it is. But at the end of the day, for a package to be APR preferred, that polypropylene or polyethylene blend density needs to be less than 0.97 grams per centimeter cubed. If it's between 0.97 and 1, we're going to ask that you test. And if more than 95% of that item floats when tested via our sink float screening protocol, it could still be considered preferred. If between 51 and 95% of that material floats, it's detrimental. If less than 51% of that material floats, it's going to be classified as non-recyclable. And without testing, if the blend density is greater than 1, or if you do test and more than 51% of the item, less than 51% of the item floats, then that's going to be considered non-recyclable. So brand new guidance that is just finally approved today. So from there, I'll kind of move into some generalizations in our design guide, kind of rules of thumbs that you could start with. So for PET, clear, transparent, light blue or transparent light green are preferred. Other colors are detrimental, and the reasoning behind that is that it's really bottle to bottle that we're trying to push, right? And it's clear PET to clear PET. So other colors are considered yield loss, and the market for other colors is much lower than the market for clear PET, and those other colors are typically from a reclaimer perspective sold as a loss, and any color is not recyclable if it's not IR sortable. Closures should be polyethylene or polypropylene. Labels become much more complex because there are a number of label opportunities for PET bottles. But for direct printing, we want that ink to flake off. Pressure sensitive and wraparound labels, we want that to be a floating polymer, so a polyethylene or polypropylene label with an adhesive that removes during the wash process and ink that adheres to those labels. Paper labels are always considered detrimental. And for full body shrinks, either a polyolefin full body shrink label with ink that adheres to that label, or CPET label with ink that flakes off during the wash process. In terms of closures or pumps and triggers, we want all plastic closure pumps and triggers made of polyolefins, essentially, so that they float in the sink float tank and are efficiently removed from the PET bottle or container. For high density, color, natural, and white have the most value. All other colors are acceptable if they're near IR sortable. Closures, Polyethylene is the best, so a polyethylene closure on a polyethylene bottle. Polypropylene is fine if it's acceptable if it's less than 10 weight% of the entire container. I will say we also recently updated our color for closures on natural high density bottles. So we preferred is natural closure, where all other colors are detrimental. Density, again, that material needs to float, so density less than 0.97 is preferred. Labels must meet sorting requirements, plus direct ink that flakes off. Pressure sensitive labels are acceptable, but paper is detrimental. There are a family of IMLs, rain mold labels that are acceptable, and then shrink sleeves, essentially any material that's not PVC and still allows the bottle to be sorted. Pumps and triggers, all plastic made again of polyolefins. Polypropylene design guideline generalization. So again, color, natural, and white have the most value, especially in the food contact stream. All colors are acceptable if they're near IR sortable. PP closures are best, but PE is acceptable if the weight is less than 10% of the total package. Again, low density, it needs to float. Same label guidance as with polyethylene. And again, please no PVC labels. And then all plastic pumps and triggers. And then finally, maybe for thermoforms, and this one kind of combines both polyethylene and, or I'm sorry, polypropylene and PET. So in terms of materials for PET, crystalline melting temperature between 225 and 255 degrees C, as is specified in our PET bottle guidance. Density 1.38, right? So this is again where we want that density above 1 so that it sinks in the sink float tank. And in terms of IV, bottle grade is preferred because that's more compatible and allows for a higher acceptance into the bottle stream. Polypropylene, all resin types are acceptable or preferred. Density, again, needs to be less than 0.97. But in this case, since foaming decreases density, a foamed polypropylene is acceptable, is a preferred structure per our guidance, and is actually specifically called out in the ISRI bail specs for polypropylene as accepted. Labels are the same guidance as for bottles. And I will say high coverage paper pressure sensitive labels are highly detrimental to the recycling stream. The caveat and the difference again from bottles and other containers is the bail acceptance and access. So for PET, thermoforms are allowed in PET bottle bales at less than 2 weight%. And they are allowed in PET bottles with PET thermoform bales at less than 10 weight%. Polypropylene thermoforms, there's no limit in the polypropylene bales. And then when we think about making unqualified claims, again, we need to still consider the access, which is at 54% for PET thermoforms and 59% for polypropylene as of March 2022. So with that, tons of information, and I appreciate you hanging in there, and hopefully we'll get to answer some questions. But, you know, at the end of the day, and we appreciate FPI for letting us take up some time in one of their webinars, recycling works when we all work together. And that goes from ensuring that the package is properly designed so that it makes it through a MRF, then through the reclaimer, and then you buy that reclaimed polyolefin or PET to reuse in your packaging. That's really when it works properly. So with that, thank you again so much. Contact information is here on the screen, and I will stop sharing here and maybe we can take some questions.
All right, great. Thank you, Scott. That was a great overview, very in-depth, which is wonderful. So We do have a few questions in the chat, but I do have a few also as well that I have prepped for you. So one of the questions we get a lot from members is, what about food residue in the whole reclamation process? FPI, we have done food residue studies in the past that shows, it's very minimal contamination. And it's no more, there's no more food residue than on like a retail food packaging. Are your members, concerned about food residue? Have they talked about it? Could you just maybe expand on that a little bit?
Yeah, so and one thing I didn't mention is one of our efforts that we have ongoing now is trying our best to harmonize with Reciclass in Europe in terms of package design and testing protocol. And the reason I bring that up is they actually have a test that they have to show how easily a package is empty from whatever either food residue or hand cream, whatever's in there. And maybe that's something APR might talk about encompassing later. But we don't see it as an issue at our reclaiming. I think, occasionally I was at a PET reclaimer and it was one of the only times I've seen food residue be an issue. There was peanut butter in a jar and the peanut butter on the inside of the jar made the color sorter sort that bottle as a colored brown bottle instead of a clear container. So yeah, there was a lot of peanut butter in there, but other than that, it's not that much of an issue.
Okay, great. Great, thank you. Okay, so one of the questions we got was, are you working with Cal Recycle? There are new laws that they're creating out there. Are you involved? What is your role out in California with the legislation and rulemaking process going on?
Yeah, so so Kate Bailey and Kate Eagles, both are on our policy team. They do work with Cal Recycles along with Bruce Magnani and Associates out in California. So we are, I think answering questions as they came up and giving them guidance in terms of what the reclaimers are accepting and what they can't accept in their streams.
Okay, and then a second question to that, what's the latest information on changing the chasing arrows to triangles? Do you have an update on that?
I don't know if it's an update. I mean, I think if we kind of frame the question as quite complicated, right? So, California their truth in labeling will affect whether those can be used on specific packaging formats. The complication is, the resin identification codes are dictated by ASTM 7411, I believe it is. And they suggest that you use a triangle instead of chasing arrows. And then the added complication is that I believe there are 37 states that require chasing arrows in packaging. So I have no clue what's going to happen there. I think most of the states, I believe their legislation says is not a you must use, or it's more of a you should use. So it's not going to be quite as maybe restrictive as California might be. But I don't know where that's going to land.
Okay,
I think as an APR, we suggest you use the triangle, follow ASTM rather than chasing arrows.
Okay, that's great. That's good to know. Yeah, I think there's a lot of things up in the air with California specifically.
Yeah.
Great. So one of the questions also we had was, how will a consumer or a recycler know if there's mineral filled polypropylene that meets the guidelines you outlined?
Yeah, so the consumer most likely will not know that. That's why as packaging designers, we need to design it out of the packaging as best we can. The MRF won't know it because the MRF won't be able to, they will identify polypropylene, polyethylene, not the filler content. It's only at the reclaimer where they see it as a loss in yield and it gets landfilled, which is almost the worst part of the supply chain to be lost at, right? Because there's the added cost of MRF sortation, there's the added cost of the reclaimer buying that bale, and then the reclaimer having to landfill that material after going through all the sorting and cleaning steps.
Got it. Okay, and then kind of an add-on to that is, if there is a mineral filled polypropylene package that does make it through the float sink tank, does that mineral fill, like, how does that contaminate the other polypropylene? How do you determine that?
So in order for it to be, to make it through the float sink tank, right, it has to float. So that limits the amount of mineral filler. I think for calcium carbonate in polypropylene, it's on the order of less than 8% of filler. Once it makes it in, if it continues to float, that mineral filler will just get diluted in the recycle stream. So, as long as it, and to my knowledge, nobody has a clear polypropylene stream, although mineral filled would be removed out of that because it's most likely opaque anyways. That calcium carbonate gets diluted.
Got it. Okay, understood. So there's a question also about, is there a review process for manufacturers to be able to market their package as meeting the APR design guides or design preferred? Is there any sort of review process or anything like that?
Yeah, so earlier this year, we rolled out a preferred design recognition program. And essentially what a packaging designer does, and we're still building this out, but say you have we don't have a full container yet for PET, but say you're building a yogurt container. We have a set of polypropylenes, and polypropylene's easy because essentially every polypropylene is recognized as preferred. So if you're using polypropylene, that's a good, easy start. And then we have different features where you can build up your package where your lidding falls under our preferred guidance, your printing or your label falls under preferred. And you submit the data to APR. APR's technical group, so there's 5 of us, review the submission, and then that package, if it meets all the criteria in that every design feature is preferred, you could get a preferred design recognition from us. So it's a nice frameable letter that you can put it up on your fridge at home.
Great. The break room fridge, yeah.
Yeah.
Okay, so just a point of clarification we had for the Rick. So do you have to use a triangle or can you just remove it?
You being somebody who produces packaging
Yes,
for
I believe a
California or a different
manufacturer.
state?
Yeah.
So I believe, and I would suggest you contact your legal team, in-house legal team. I don't believe it's required in California, but if you use chasing arrows, then it must meet California's criteria. So I think the resin identification code historically has been useful for plastics recycling, especially in MRFs that haven't updated to IR or automated sortation. And in that case, they would have manual pickers picking up packaging and looking at the resin identification code. So historically, it does have use, and it still continues to have use in some of those MRFs. But yeah, I guess if you're trying to conform to California and you want to be safe, then maybe remove it. But again, I'd suggest reaching out to your legal counsel.
Okay, but no specific requirement with California unless the chasing arrows.
I don't believe there is.
Okay, got it. Thank you for that. So how do you view the threat posed by compostable paperboard packaging to plastic? Are the coatings, the bioplastics coatings on those papers, do they likely work to the advantage of plastics?
Yeah, that's maybe a little bit of a stretch for APR, but I think personally there's no perfect material, right? There are better materials and formats for different applications. So if your application has one that maybe does have a lot of food contamination and you want to keep that food contamination out of the landfill, then an industrially compostable or compostable package might be the way to go over a plastic package. I mean, the added issue is that, in North America, our recycling collection and infrastructure isn't great. Our composting infrastructure and collection is even worse, right? So there's a lot that needs to be built up there, but APR, maybe just me, I think there are definitely good applications for compostable packaging materials. In
Yep,
terms of
definitely.
plastics coating on fiber, you're much more the expert on that than I
Yeah.
am as you've continued to grow the number of paper mills that accept poly-coated papers.
Yeah, there's definitely no one silver bullet. So do you have any thoughts on like PHAs, marine biodegradable plastics? And do you see them taking over at any point? Or I mean, I know I have opinions on it, but what are your
I
thoughts,
should get
Scott?
your first.
Yeah, well, so I mean, mine are, we don't want to give permission to people to litter, right? And
Yeah,
so, and a lot of times too is, if you have the certification for marine degradability, it's the resin. It's never, they're never going to certify the package, the TUV, just because of that, right? They don't want to see the litter and the impact. So,
yeah.
yeah.
So I think as you talk about not just PHAs, PHBs, but that family of materials, right? I think Closed Loop Partners did a study that said that people, if they see compostability, people are more likely to think that they can litter it and it'll just go away in the environment. And whereas that might be kind of a accurate in terms of some of the PHAs and PHBs available on the market, right? You're still losing the value of that material in the stream. So, even I think Total Corbion and Nature Works have moved away a little bit from compostability, and they want you to mechanically recycle that material because there's embedded energy and greenhouse gases in the production of PHAs, PHBs, PLAs, PBATs, any of those compostable materials, right? And when you put those in the composting stream or they unfortunately end up in the environment, first of all, they end up in the environment. So that's even worse than the greenhouse gases and energy that is embedded in them. But, keeping materials in the economy, I think, is where we want to focus. But again, as I mentioned, there's no perfect material. They're just, in some cases where there's a lot of food waste, maybe you do want to keep that into the composting stream. And that's where a PHE or PHB, I think, has value.
Yep, definitely. And I know you caught yourself earlier, but compost biodegradability does not mean compostability. So I
Yeah.
appreciate that catch. Final question, because we're at time here almost. So who performs the MRF sorting recyclability testing? That's for your testing. Where is that done? How is that done? Or who does it for you?
Yeah. So on our website, we have a list of testing companies that can do that for you. The ones off the top of my head that can do the broadest range of testing, PFE, PTI, Ideopac, and then for the 2D, 3D sortation, that's done at Van Dyke. If you just want to do near IR, again, Tomra, MSS, Van Dyke, and a number of others can do that as more of a one-off type of testing. But yeah, check out our website for the full list.
All right. Well, great. Thank you, Scott Trenner from APR Technical Director. The recording will be available shortly in the next couple of days, and then posted on our YouTube channel. Thank you for joining us this afternoon, and I hope you have a great day. Thank you.
Have a good day. Thanks, everyone.